Let's look at a few examples of how to simplify square roots using the quotient rule. So just a reminder, there are three things that you're looking for with simplest form in radicals. You can have no perfect square factors in the radicand. So for instance, the square root of 8 is not simplified because that breaks into 4 and 2, and 4 is a perfect square. You can't have any fractions in the radicand, so the square root of 1/4 is not simplified, and we're going to look how to take care of this issue. And the final thing is you couldn't have something like 1 over the square root of 2 because it's a no-no to have a radical in the denominator. Remember, this process to get rid of it is called rationalizing the denominator. So the quotient rule says the square root of a divided by b is equivalent to the square root of a over the square root of b. So let's put this into practice. So the first one, square root of 6/25. First thing I always do is I check and see, can I simplify the fraction that is underneath the radical sign? Nothing goes into both 6 and 25. So then I apply my quotient rule, which says separate this into two separate radicals, the square root of 6 over the square root of 25. Now, why is that helpful? Because I know the square root of 25 is 5. Hopefully you don't need a factor tree to see that. And the square root of 6 has no perfect square factors, so this is simplified. It fits the three conditions. All right, square root of 2/18. First thing I do is I check and see, can I break down 2/18? Meaning, can I simplify this? Well, that's equivalent to the square root of 1/9 as a reduced fraction. Using the quotient rule, split this into two separate radicals. And these are both perfect squares. The square root of 1 is 1, the square root of 9 is 3. Okay, let's look at a more complicated one. So again, I check and see 4 over 3. That does not reduce as a fraction, so using my quotient rule, I'm going to split this into the square root of 4y squared over the square root of 3x. Well, up top, I have two perfect squares. Square root of 4 is 2, the square root of y squared is y. But the denominator has a problem. I have a radical down there. So this is where I do the process of multiplying by a disguised form of 1. And the form of 1 I'm going to use is the radical that's in the denominator. So I'm going to multiply top and bottom by square root of 3x over 3x. This results in multiply your numerator together, which would be 2y times the square root of 3x, because I have to multiply coefficients together and radicands together. The denominator leaves me with just 3x. Now, quick reminder off on the side, if you don't remember y, square root of 3x times the square root of 3x is the same as the square root of 9x squared. Well, square root of 9 is 3, square root of x squared is x, so I'm left with just the base. Or you could think I'm squaring and then unsquaring, so of course it leaves me with the base. Okay, I'm simplified now. You should always check your coefficients to, didn't mean to scribble that, 2/3. Check and see if that reduces. It does not, since they're both coefficients. And don't accidentally make the error of reducing this x and this x, because one's under a radical and one is just a coefficient. So final answer is 2y times the square root of 3x over 3x.